So I wanted to give another example of this modeling, and so what I have here is an adiabatic OCAES system. So if we look at the compression phase of the system, you'll see a lot of similar blocks as to what we had before. And the main difference here is that we have thermal masses, which are simulating thermal energy storage. So at the discharge of each compressor, the flow enters the thermal mass, and the airflow cools down, and the thermal mass gains heat. And so we do that 3 times, and before the flow enters the storage tank. And so if we want to look at the thermal mass, it's something new here, and so you have the overall heat transfer coefficient, a thermal mass, initial temperature, and then you can add heat transfer with the environment. And so what we're doing is we're monitoring the temperature of each mass over time, and then we're taking the average of them, so we can see how the thermal masses gain heat during the compression phase, and then during the generation phase down here, we're doing something similar where we have 3 thermal masses at the inlet of each turbine. And so what we'll see is over time these thermal masses will cool from their initial temperature. So we can go ahead. So we've run the system, and we can see what the effects are on the thermal masses. So here in this plot we can see what how the thermal mass gains heat over time. And keep in mind we've only run it for 10 seconds here. During the actual modeling, what we ran it for 10 to 15, the equivalent of 10 to 15 hours. It obviously doesn't take that long, but just keep in mind when looking at the temperature on the left. And so on the left is temperature in Celsius, and we see the first thermal mass gaining temperature more quickly, and the second one a little bit less. The third line is actually the average of the 3 thermal masses. And then the bottom line is actually of the last thermal mass, which is that particular compressor is not doing any work initially, and so there's no gain in temperature. We also have these tags here, and we can put these wherever we'd like, but what it allows us to do is monitor the instantaneous mass flow rate, temperature, and pressure at each point in the system. If we look at the generation phase, we have something similar, and so these thermal masses should be cooling down with respect to time. So if we take a look at the plot, sure enough, so you see the initial temperature was a little over 480 C, and the first thermal mass decreases more quickly, and so on. And then finally, we're monitoring the turbine pressure or turbine power output and the compressor power input for each of the 3 turbines and 3 compressors, and that allows us to calculate the efficiency of the system. So I hope that this gave you an insight into the thermal modeling, and so I hope that you consider this type of method for design of future thermal systems, or especially CAES and OCAES systems. Thanks a lot for watching.